Hello everyone, welcome back to my channel. Now that we have defined the notation used in the neural networks, let us formally describe the forward propagation process. Forward propagation is the process through which information travels from the input layer to the output layer to generate a prediction. Consider any layer I in the network. The first computation performed at this layer is called the pre-activation calculation. Mathematically, the pre-activation vector is given by AIX equals to BI plus WI times HI minus 1x. Let us understand the equation carefully. Here, HI minus 1 represents the output coming from the previous layer. WI is the weight matrix of the current layer. BI is the bias vector and AI is the pre-activation value. In simple terms, we multiply the outputs from the previous layer by the corresponding weights and then add the bias. If a layer contains multiple neurons, this computation can be written in matrix form as shown on the slide. Using matrix operation allows us to compute the outputs of all neurons simultaneously, making neural network computationally efficient. Once the pre-activation value are computed, we apply an activation function. This gives us the hidden representation Hi equals to G AI, where G represents an activation function such as ReLU, sigmoid, or tanh. The activation function introduces nonlinearity, enabling the network to learn complex patterns from the data. This process is repeated layer after layer. Eventually, we reach the final layer, often denoted by L. The output of the network is given by f of x equal to HLX equals to OL of x, where O represents the output activation function. So, the forward pass consists of the following simple steps. Compute the weighted sum plus bias, apply the activation function. Third, pass the result to the next layer. By repeating these steps across all layers, network produces its final prediction.